Hey everyone. So previously we were talking about moles and we saw that moles was the amount of substance. Now we could be calculating moles from solids, liquids or gases. From solids we know that we measure the mass of the substance in obviously grams. We divide the grams by either molecular mass or the atomic mass and then we calculate the moles. For gases we measure the volume, which is either decimeter cube or centimeter cube, and we either divide it by 24 or 24,000 to find out the moles. In today's video, we're going to be talking about liquids. Liquids are measured in concentration. So today we're going to see what concentration is. So today's video is going to be about concentrations of solutions. Imagine we have 4 different solutions labeled A to D. Now we can see that the color of the solution is similar but not exactly the same. It could be because one of the substance is really dilute solution, the other one is perhaps a more concentrated solution. They are solutes the same nature, but their amounts are different. One has lots of water in it, while the other solution has more amount of the solute. It has a lot of solute in it. If we look at the microscopic diagrams, and if I try to draw water molecules over there, you will be able to notice that the water molecules will have different amounts of solute dissolved. For example, a purple circle is the solute. You can see that one has less moles of solute, the other one has more moles of solute. And this represents that the amount of solute dissolved in the same amount of solution is different. So concentration of solution becomes the amount of solute, which is obviously moles, the amount of solute in moles dissolved in 1 decimeter cube, or you can say 1000 centimeter cube of the solution. We always talk about 1 decimeter cube of the solution. For instance, I have 1 decimeter cube of a solution, for example, sodium chloride solution, which has obviously 1000 centimeter cube. And I say that I dissolve 1.5 moles of, for example, NaCl over here. Now 1.5 mole is dissolved in 1 decimeter cube. So the concentration is 1.5 mole per decimeter cube. Similarly, for example, I talk about some other solution as well. If I say that I have, for example, 500 centimeter cube in some other case, which is not 1 decimeter cube, I have 500 centimeter cube and 0.8 mole of KMnO4 is dissolved over here. Now I cannot quote my answer in 500 centimeter cube. I still have to quote in 1 decimeter cube, or you can say 1000 centimeter cube. So I will do the conversion over here. And my conversion would be that 1000 centimeter cube would be carrying double the amount. And now my concentration would be quoted again per decimeter cube. If 500 has 0.8 moles, then obviously 1000 would be having 1.6. So the concentration is 1.6 mole per decimeter cube. We are now clear with the concept that concentrations are always quoted with mole per decimeter cube. So the unit of concentration would be mole per decimeter cube. We can write it either like this or mole per decimeter cube with a slash. That represents the same meaning, that the amount of solute per decimeter cube, which means one solution could be very dilute with less amount of moles of the solute, or the other could be more concentrated solution with more moles of the solute. Let's try out some worksheet questions and let's see which formula we'll be using. And this formula is moles is equals to volume of the solution multiplied by concentration of the solution divided by 1000. So this formula is really going to be important for us. We're going to be constantly using this formula, which is CV divided by 1000. And we're going to keep using this formula to calculate either moles or volume or perhaps even concentration. Let's see some questions over here. If I do, let's suppose question 1, obviously, we can say that question 1 says calculate the moles in 30 centimeter cube of 0.05 mole per decimeter cube. Moles, volume, and concentration are all three given to us. Now we know that moles is missing, so we'll solve the formula, which is mole is equals to CV divided by 1000. Moles is missing, but the concentration is 0.05 times volume, which is 30 centimeter cube divided by 1000. Now if we solve it, for example, if we solve it using a calculator, 0.05 times 30 divided by 1000, the answer is going to be 1.5 exponent minus 3 moles of obviously sodium hydroxide. Let's do some other question over here. I'll change the color. Now it says calculate the moles of potassium hydroxide in 15.6 centimeter cube of 0.6 mole per decimeter cube of potassium hydroxide. Again, the moles are missing, volume is given, and mole per decimeter cube means concentration, so that is given as well. Now we'll solve it to see what happens. Mole is equals to CV divided by 1000. We know that moles is missing. We know that volume has a value of 15.6 and concentration is 0.6. We divided by 1000. 0.6 times 15.6 divided by 1000. The final answer is gonna be 9.36 exponent minus 3. Again, mole of potassium hydroxide over here. So we can quote the answer in either standard form or the scientific notation. Let's do question 3. It seems a little interesting. Question says calculate volume of 0.05 mole per decimeter cube. I'll underline it as well. So we need the volume over here. 0.05 mole per decimeter cube solution, which is obviously concentration, that contains exactly 0.04 moles. So we know that apparently volume is missing. 0.05 mole per decimeter cube means concentration, and the mole value is also given, which is 0.04. Let's put the same formula, but let's see how we tweak it. CV divided by 1000. We know that moles is given 0.04. Even the concentration is given, which is 0.05. Volume is missing, so I just put VOL over here. 1000 is a mathematical constant. We shift few values on the other side of equality. So 0.04 times 1000, because 1000 goes on the other side of the equation, divided by 0.05, so we can calculate the volume. 0.04 times 1000 divided by 0.05 would be equal to 1000 divided by 0.05, 800 centimeter cube is the answer. So we need 800 centimeter cube of the solution over here. So we can use the same formula to even find out the volume. Let's do question I believe 5, I guess. Let's try this one. How much volume will be needed to contain exactly 0.006 moles of copper chloride if the concentration of the solution is 0.004? So again, it seems like the volume is missing. The mole value is given, which is 0.006 moles of copper chloride, and concentration is also given, which is 0.004. Same formula over here. We do the same putting of the values. Moles are put. We put the concentration over here. Volume is missing. 1000 is still the mathematical constant over here with us. Volume can be calculated by 0.006 times 1000 divided by 0.004. Yeah, we get to know that 0.006 times 1000 divided by 0.004 should be somewhere above 1000. It's 1500 centimeter cube. So we need this much volume of this concentrated solution to find out the moles that we need. So we saw we can use the same formula for differently concentrated solutions, and the concentrations are here with us. So We are going to be talking about stoichiometry in the upcoming videos, so we're going to make sure that we keep using all the formulas that we have done so far. So stay tuned, guys.